As we continue on, going on now to topic 2 of chapter 5, we're dealing with polynomial functions, and the operation specifically will be adding and subtracting. And a lot of you may know a lot of stuff here, so this is just review. Now, what's an expression in algebra? By definition, an expression are those items separated by a plus and minus sign. And these items then are called terms. So this is a term, and this is a term. That would go in that column. This is a term, along with the negative sign, that is a term. And this is a term. And this is just a term, and this is just a number. And you might say, what's the difference between this and this? Well, this has a variable in it. This doesn't. Now, interestingly, as we look at polynomials, they are a series of expressions made up of terms. And if we have a polynomial that only has one term, we give it a special name. We call it a monomial. Mono being the prefix for one. Here, this expression has 3 terms, so it's called a trinomial. This one has 2 terms. It's called a binomial, like a bicycle with 2 wheels. Okay, so I've identified the terms. Now, each of these terms also have what are called numerical coefficients. Now, we did some of this in chapter 2, but again, we're reviewing a little bit. So what would be the coefficient of this? Well, it would be a 4. And the coefficient of this would be the 3, along with the positive sign. This will be a 9. This would include the negative, a negative 7. And in the case of a negative 1, we're going to see that that's a constant, and that's also its coefficient. Here, the coefficient is 7. So we're going to be asked to identify these things as we go on, and you'll be asked in your practice and quiz me. And I know I've mentioned this many times, but again, your textbook, which I have over there, is your major source. This is just supplemental, going over and giving you maybe a few things. Remember, I'm not going to sit here or stand and read it to you, but you should be looking over your textbook to pick up on background, although I try in the short time to give you what we can. Now, for instance, in example 1, they want us to find the degree of the polynomial. Now, what is meant by the degree of the polynomial? Well, it's the sum of the exponents on the variables in a particular term. That's what the degree of the polynomial is for individual terms. Now, when we get an expression, it changes just a little bit, but let's do the terms first. So here we see this is x to the second. That's all we have. So the degree of this one is 2. Now here, since this is not a variable, we do not count that exponent. Degree is only on the exponents on the variable. So the degree of this term is 5. Now we said every term has a 1 by it, so the degree of that one is 1. Now here we have 3 letters. Keeping in mind on the y we have a 1. So 2 plus 1 is 3 plus 3 is 6. Now as you look at example E, it doesn't have a variable. We might think of it, though, as x to the 0. We just had that in the previous section. Now, that's not there, but we might think of it being there. So on this variable, again, that's not there, its degree is 0. So anytime you have a constant, its degree is 0. Okay, in this case, they want us to find the degree now of the expression of the polynomial. So this is a trinomial made up of 3 terms. So what is the degree of this one? Well, this one is 2, this one is 1, and this is 0. This one is 1, and this is 0. This is 1, this is 3, this is 2, and this is 0. Now, I put this one up because they're not giving you one like this, but I think this is important. So what's the degree of this term? Keeping in mind that these are 1s. Well, the degree of this is 4. This is going to be 12, 16, and this is going to be 6. Now remember, the degree of a term is the sum of the exponents on the variables. So now that we've identified the degree of each term, what would be the degree of the expression, that is the polynomial? Again, the definition for this is the highest degree of any one term. So what's the highest degree of this one? A 2. So that's the degree of this polynomial. Here, it'll be a 1. Here, it's going to be a 3. And here, it's going to be a 16. Now, don't make the mistake, I hate to say this even, of adding all of these together and saying that's the degree. No, the rule is it's the highest of the individual term, just the one. So you figure out the degrees of the terms, and then the highest of that is the degree of that expression. Critical. Lots of students make errors on that one. All right, now we're moving on to specific examples, and by the way, we skipped example 3. I covered that in the previous part. All right, find the following. Here they're giving you function notation, where they're saying the function of x is this, or p of x is this. And they're asking us to substitute as values of x here, a 1 and a -2. Now, this is sort of stuff we used in Chapter 3, a modified t-chart, and that's what we're going to do here. So the key is that as you substitute for the x, a good idea, put it in a parenthesis. That way you can be careful of your signs and execute what you need to. Now here, this is just 1 squared. 1 squared is 1. So this becomes a 3. Minus 2 times 1 is a -2 minus 5. So we have a -7 and a +3 gives us a -4. So this is input and this is output in function. So here this is going to be a -2 times -2, a +4. Times 3 is 12. This is going to be a -2 times a -2 is a +4 minus 5. So we have a 16 minus 5 gives us an 11. Now, you might be able to do some of this in your head, but again, when you're taking a test, you want to really be sure because you don't have any, backup. You've put your answer in. All right, going on to example 5. Here we're finding the height of a falling object. Well, here we have this tall building. It's this many feet high. We're going to drop something off of that tall building. And we're wondering through time, what will be the height of that before it reaches the ground? Now the function formula is P of t equals this. So this is your starting height, and it's negative slope in a sense, and we're going to square the t. So they give us two values of t, a 1 and a 6. So we put the 1 in there, square it, negative 16. So we subtract 16 from this and we get that. And then here, keep in mind you have to square the 6. That becomes 36 times a negative 16. Then you're going to subtract it from that and you end up with 16.1. Now, my question to you is, where do you think it will be in 7 seconds, I should say? Right, on the ground. It has hit the ground. Okay. A question might be, how would you figure out the exact? We're not doing that one right now, though, but you would put a 0 there and just solve for your t. That comes up in later chapters, not in your course. And we're building, as we go on, like terms, unlike terms. Now these are all terms, but some are like terms. Well, what makes something a like term? By definition, if the variable, including the exponents, are pretty much or exactly the same, these are like terms. Here, this is a 1, this is a 1. These are like terms. Here, this is an AB, this is an AB, or in this case it's a BA, but remember we're allowed to shift those, switch them in position, commutative principle. So even though it's not exactly alike, that's why it is considered a like term. Now over here, as we look at the variables, we see here this is exponent 1, exponent 2, so they're not like terms. Exponent 2, exponent 1, not like terms. Here the A is to the second, here the B is to the second, so they're not like terms unless the exponents are pretty much exactly the same. Again, we could switch these around and they would be exactly the same. Now as we go on to example 6, we're going to start using what we've been developing, combining like terms. Now, what are our like terms here? Well, again, these have the same variable. Uh-oh, this is a little trick here. These are not like terms, so that's as far as you can go. But these are like terms here. This is a like term, and then these are like terms. Now, a technique might be one that I've used for this, that this wasn't the original example. As I started to copy it down, I put my like terms together, which is a good technique. And this is only that. So, as we do these then, when we combine like terms, we only deal with the numerical coefficient. The variable stays the same. So that's going to be an x. So a -3 and a 7 give me a 4. This we can't do. That's as far as you can go. Now remember, there's a 1 there. So this gives me a 10x cubed. Now here it's a good idea to keep your sum method. And again, if I were copying this, I may have written this and then these two together. So this becomes 13x squared minus 2, a positive 5, negative 7. Now for this one, they wanted you to work with fractions a little bit. So in order to combine these like terms, I have to make this a 10 by multiplying it by 2. So this then becomes 4/10 plus 1/10 in a sense, x to the 4th. And here I have to make this a 6, back from chapter 1 when we did stuff like this. So this becomes 4/6 minus 1/6 x to the 3rd. I'm allowed to do that. And then just my x squared. So now this is going to become 5/10, which is 1/2 x to the 4th. This is going to become, again, a 3/6, which is a 1/2 x to the 3rd minus x squared. So you'll be using some of your technique from earlier chapters in getting, if you're dealing with fractions, to get equivalent fractions so you can add them. As we move on to these examples, I'll be giving you a strategy that might be useful a little bit further up our lesson here. But as we look at this polynomial, let's do a little review. The degree of this is 2. 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 So everything is 2. But what are my like terms? Well, the only like terms that we have are these two terms. So we usually try to keep it in some sort of order, starting with our x term here. So this will be 9x squared. Now 3 plus 7 is a 10 xy. Remember, the variables never change. 5y squared. So some will get a little more complicated. Again, it's a matter of identifying the like terms. Now, in our textbook, they have a much nicer picture for this, and this is example 8. And I guess we're on the next page now. But here they're trying to show you sort of what is going on. Now here we're saying this length is x and this length is x. So this is an x squared. And this length is x and this height is 3. So this is a 3x. And this is 3 and this is 3, so this is a 9. And this is 4x. And this is going to be 2x squared. So we're going to try to give a sum for this by combining like terms. Well, what are my like terms? Well, I have x squared and I have x squared. So I have 2 of those and 1 of those, so that gives me a 3x squared. Now I have a 3x and a 4x. Add those together, I'm going to get a 7x, and I have a single 9. So when you see a trinomial that looks like this, it might be a representation of various areas that were these sort of figures. Again, my figures aren't exact, but to show you and illustrate what it's like. So, again, strategy. What's going on here? Well, there's 9a, and it looks like they want us to add. which is in a sense combining like terms. But they have it in two sets of parentheses. Now if you have a parenthesis and a plus and another parenthesis, it's okay just to take away the parentheses. And now combine like terms. And that's the same here. When there's a plus, you can just take away the parentheses and you're going to combine like terms. So here it's a matter of identifying the like terms. This is a like term, this is a like term, and this, and this. And over here we have a to the third, so that's all by itself. We have a B and a B, and an A, and an A, and then something over there, and there. Okay, we sort of identified the like terms. Now we're going to do our combining. Well, here this is a 7, this is a 6, so it looks like we end up with a 13 x to the third y. There is no other like term for this, so we'll just stick that in. And then we have this minus 4 will give us a plus 7. Now here there's no a to the second, so we just keep that. Now our negative b and our positive b, they just cancel out. Now we have a plus 2a and a plus 1a will give us a plus 3a. And here the 5's just cancel out. So again, as you do your practice, you have to be very careful in identifying like terms and then just combining them. All right, I'm skipping 11. 11 is very similar to the one we just did, but we're going on now to subtracting. How can you tell that we're doing subtracting here? Well, because of that negative sign between the parentheses. And here's where we're going to do some modification. Now here there's plus in a sense out in front, so we can just take away that parenthesis. Now we want to take away this parenthesis too, but in order to do so, the rule is we have to change all these signs inside the parenthesis. Make them the additive inverse of what they are. So this was a positive, that will now become a negative. This was a negative, it will now become a positive. This was a positive, now it'll become a negative. And now we can take away our parentheses. I'm going to make this a nice dark negative here. And this is a nice plus. So the rule is, if you have a negative in front of a set of parentheses, you take away the parentheses, change all of the signs to each of the terms inside the parentheses, and then you just group like terms. So subtraction is just that little modification. So these are like terms. This is a like term. And that's a like term. So now it's just a matter of adding them up or grouping them. A positive 2, negative 2, these are going to cancel out. A positive 8 and a positive 1 give me a positive 9x squared. Remember, variables don't change. Now there was no like term actually to this. Shouldn't have put that there. This is a negative 6x and a negative 1. we have completed our subtraction by actually converting to addition and combining like terms. Now here, for example 12, we're mixing words a little bit with our process. So here we're told to subtract this from the sum of that. Now again, a strategy would be, what do we do to subtract something? So this is sort of like a parenthesis with a minus sign. So take away the parenthesis, this becomes a negative 5z. This becomes a negative 7. Oh, opposite sign, a positive 7. We had to change both of these signs. And that's an error students sometimes make. They'll only change the first one. So now this indicates subtract. And then we can just remove the parentheses. And there's our example. So the key, if it says subtract something, we have to change each of these signs to their additive inverse. So we can add these two together and get a 17, subtract the 5 and get 12z. Then we get an 18 minus 2 gives us a 16, and that's our answer. Now as we do example 13, I said I would show you another method that might be helpful. Now these are horizontal, so for this one we know we can just take away the parenthesis. And now we're going to subtract by changing each of these signs. I'm going to make this one a plus. I'm going to make this one a minus. And this one a plus. Take this away. And now I want to combine like terms. But one of the techniques I'd like to mention that you might do, if they get a little more complicated perhaps than this, is to line these like terms up vertically. So I have this as a like term. So I'm going to put this underneath it. This is a like term with this, so I'm going to put it vertically underneath it. And this one here as well. Now, by doing so, I have created what I call vertical like term columns. We don't want to eliminate anything. And then we just put a line underneath it and add them up. So this is going to be 10 y squared. Remember, the variables don't change. This is going to be a negative 14 xy. We have to put the plus there. And this is going to be 5x squared. Okay? And that will wind up section 2 of chapter 5.